Welcome everyone. So today we are going to talk about various phases or forms of linear functions. And there are four in total. You may have seen a couple, perhaps these two maybe, or maybe these three. It's kind of rare to see this one, but I think this is really useful and helpful. So I want to address all those four forms or phases of linear functions. It's almost like you have a first name and you have a last name, and they don't sound the same. You don't write them the same way, but they're referring to the same person. Same thing. There are four faces to the same linear function that you might work with. And you can actually go back and forth between all of these as you wish, and we will do that. Now, before I begin, let me just say that none of these four forms is better than the other. You can't say, well, this is the most useful just because you've seen it most, okay? Which one is better? The answer is it depends on the context. So for instance, let's start with the one that you are most familiar with. It's called the slope-intercept form. The reason we call it the slope-intercept form is because the two parameters you would need to find in order to have control over this machine is m and b. And m is the slope, otherwise known as the rate of change or the multiplier. And this is called the y-intercepts because when x is 0, y is b. When x is 0, y is b. So this is called the y-intercepts, the initial value, initial heights, initial weights, initial number of fish in the sea, initial number of trees before they were cut, right? Initial anything. And that is your rate of change. Slope-intercept form, okay? So if the slope and the y-intercept are given to you, it's no-brainer to use this one, obviously. Even if just the slope and an extra point given to you, it doesn't have to be the y-intercept. Sometimes we use this because if a point is given to you, you could just plug it in here and get the b value, okay? Now, what is unique about this form is y is being isolated. In all of these four forms, this is the only form where y is being isolated. So if you want to put in a function on your graphing calculator, definitely you need this form, right? If you're dealing with a linear function, you're not going to write it this way or this way or this way. You would have to isolate y in order to input the information, okay? So this is called slope-intercept form, and the two parameters are m and b. M is the slope, and b is the y-intercept. The second form, this is also extremely important, especially in higher mathematics. It's kind of a linear combination of x and y. What it says here is all the x's and the y's are on one side, and all the constants are on the other side. The three parameters are a, b, and c. Now don't think that a is just a number like 5. A is the number of x's. So if you have 2x, that means you have x plus x. Are you with me? So that's why I said all the x's and the y's are on the left-hand side, let's say, and all the numbers are on the other side. So if I have, for instance, 3x plus 4y equals negative 10, this is the only actual number. This is not a number. That's the number of y's. That's a y plus a y plus a y plus a y, okay? And that's the number of x's, okay? So don't think, because when I said all the numbers have to be on this side, you might say, what are you talking about? C is on this side, but B is here and A is here. Shouldn't they be here? No. These are the number of x's and y's, and these are the constants. And this form is very, very useful, okay? The third one is called the point-slope form. The point-slope form. Slope, obviously, right? You don't see the slope here, by the way. And we can find it, but you don't see it. But in here you see it. That's the slope. And the point is actually x1 comma y1. So if I give you a point, let's say I give you a point, let's say 5 comma 6. a point, and I give you the slope, what method, what form would you use? Of course, you're going to use the number 3 form, this one. Because x1 is just 5, y1 is just 6, and m is 5, and you're done. You can leave it like this. There's no reason why you cannot leave the function written in this form. Okay, this 5 is this, and that 5 is that. Okay, I'm sorry, I should have picked a different number. Now, most kids like to write this like this, right? I don't know why. Why do you have to always resort to this form? This is perfect. There is nothing wrong with this. So if I say, give me the linear function that goes through this point and has this slope, you immediately say, okay, I have a point and I have the slope. Therefore, point slope form is the best one. Boom, done. You could just leave it like this. There is no need to isolate y and write this in this form. There is no need for it at all, okay? And that's why I said none of the forms is better. It all depends on the context, okay? Then the last one, which most likely you're not familiar with, it's called the Two Intercepts form. This A is the x-intercept. It's where the line hits the x-axis. And this B is the y-intercept, where the line hits the y-axis. This B is the y-intercept, like that B, literally. But this A is the x-intercept. It's actually, the x-intercept is written like this, right? And the y-intercept is written like this. So if I know my x-intercepts and I know my y-intercepts, this is probably the best way to do it. And it's awesome. Let me show you. So let's say I say to you, please graph x over 2 plus y over 5 equals 1. Most kids would do this. Y over 5 equals 1 minus x 2. Y is 5. 1 minus x over 2. Common denominator. And you spend half an hour to write this. Eventually, you're going to get to here, I believe. Let me see. No. Negative 5 over 2x. See, why? Why bother? Why do you have to use the slope-intercepts form? You don't have to, okay? This is a perfect form. We know that this is the x-intercept and this is the y-intercept. So you can very quickly graph it. Here is 2. Here is 5. And here is your line. You can find slope if you want. By the way, if you want to write it in this form, you don't need to do the math. You could just find the slope. Slope is 5 divided by negative 2. Remember, slope is y minus y over x minus x. I'll repeat. Y minus y over x minus x. Feel free to do this. Y minus y over x minus x. You will get the same answer. And that is minus 5 halves. So if you want to write it in this form, it's no big deal. Slope is negative 5 halves. And the y-intercept is known. Fast. I went so fast from here to here. And I don't have to waste my time doing what I was doing earlier. Cross multiply, move this here, multiply by 5, write in this form. You could very quickly graph it. You can easily find the slope. Notice that the slope is negative because the line is facing this way. Slope is always negative this way. And if the line is facing this way, the slope is always positive. So if you end up with 5/2, you know you're wrong, okay? And the y-intercept is right there. Just copy it. It's the b. This b is exactly that b, okay? So let's do another example. Let's say I say, excuse me, let's say I write x over 3 plus y over 4 equals 2. Now, notice this form has a 1 in it. You have to have a 1. So what do? We have to divide across by 2. Okay? So you're going to get x over 6 plus y over 8 equals 1. And now, this is your x-intercepts, and this is your y-intercepts. See how fast I can easily find the slope if I care. 8 minus 0 over 0 minus 6, which is negative 4/3. And if I want to write the first form, mx plus b. See how I went from that form to that form fast? Okay, you don't have to, but if I say to you graph it, it's easy, right? 6, 8, done. Done. I did this because I want you to figure out how to deal with the 2. You've got to divide everything by 2. Okay? Because you have to have a 1 here. So let me push you a little bit. Imagine I give you this now. X over 3 minus 2x over 3 minus y over 5 equals 1. Okay? Now, the 1 is here. So that's good. So I like 1. Don't divide everything because now you're going to screw up the 1. So the 1 has to stay. Now you need to have a plus here, right? In the middle. So that minus can just go to the bottom, can it? Can't it? Now what do we do with this? That's a problem. How do we handle that? What do? Pause the video and think about this. Okay, so what did you do? Did you decide to divide by 2 and divide by 2 and divide by 2? If you divide by 2, that 2 goes away, that's good, and that becomes a 10, that's good, or negative 10. But then you would mess up the right-hand side. It becomes a half, and you can't. You have to have a 1, okay? So what do? Very simple. You take it underneath 3. Becomes 1.5. Think about it. If I have x over 3/2, isn't that the same thing as x times 2/3? And isn't that 2x over 3? So if you don't like a number at the top, you cannot just bring it to the bottom and call it 6. You have to bring it underneath 3. Underneath 3, like this. So that 2 here goes right there. And now you have x over 3/2 or 1.5 plus y over negative 5 equals 1. And you know your x-intercepts, and you know your y-intercepts, and you can do anything you want. Okay? All right, so I'm going to stop the video here. I can go on for another 2 hours, but I think this is enough. Just a quick introduction to the 4 forms and a couple of ways of how to go back and forth between them. And I focus on this today, okay? Now, by the way, when I gave you this, it was easy to get here, right? And when I had this, didn't I have 2 points, A, comma, 0, 0, comma, B? So you have a point. In fact, you have 2 of them. And it was very easy for us to find slope. So it's not hard to do this, because here is the slope. Whatever you find the slope for here, instead of putting it in here, you could put it in here, and you can copy one of these points. this point, you can copy this one or copy this one. So we'll do a lot of problems with these. But these are the 4 forms. None of them is better than the other. Each one serves a purpose. And the best of all, you can go back and forth between all these 4 if you wish. Okay? All right. Take care.